Welcome to another deep dive, everyone. Today we're going to be looking at a physicist who really shook things up,
Oh,
Louis de Broglie.
definitely.
We've got excerpts from a biography about him, really focusing on his scientific work and contributions.
Sounds good.
But get this.
Yeah.
De Broglie proposed that electrons,
Mhm.
those tiny particles we all learned about?
Right.
They're not just particles, they act like waves, too.
It's true. It's that wave-particle duality.
Yeah,
And it's really a cornerstone of quantum mechanics.
definitely.
And the thing is,
Yeah.
de Broglie's background is fascinating.
Oh, how so?
Like how it might have led him to this revolutionary idea.
Okay.
He came from French nobility,
Really?
initially studied history,
Interesting.
and then made this huge leap into physics.
Wow, so that makes you wonder
Yeah.
if that broader perspective, that ability to connect seemingly different fields,
Yeah.
helped him see what others missed.
I think so.
So how did he even come to this idea of matter behaving like waves?
Well, his wartime work
Okay.
seems to have played a role.
Uh-huh.
He worked on radio communications.
So radio waves.
Exactly. Invisible carriers of information.
Right.
That was de Broglie's daily focus.
Okay.
So maybe that experience
Yeah.
primed him to think about matter in a similar way.
So instead of just signals traveling through the air,
Yeah.
he started picturing electrons with their own wave-like behavior.
It's wild, right?
Yeah, that's wild.
And he went further
Okay.
than just electrons.
Mm-hmm.
In his 1924 PhD thesis,
Okay.
he boldly stated that all matter,
Wow.
even macroscopic objects,
Okay.
have wave-like properties.
Hold on.
Yeah.
So my coffee mug,
Yes.
this table,
hmm
they all have wave-like properties.
According to de Broglie. Yeah.
How can we even begin to grasp that?
Well, it's all thanks to his famous equation.
Okay.
Lambda equals h over p.
Okay.
This equation links the wavelength of a particle. Yes, to its momentum,
Okay.
using Planck's constant.
Got it.
Essentially, it's saying that even a baseball has a wavelength,
Really?
but it's so unbelievably small
Right.
that we don't experience it.
In everyday life.
Right.
So this equation was revolutionary,
Oh, yeah.
but he needed evidence.
Of course.
How did he move from the theoretical to the tangible?
Well, scientists didn't have to wait long for confirmation.
Oh, really?
G.P. Thomson
Okay.
and Davison and Germer,
Okay.
they conducted electron diffraction experiments.
And what did they find?
They showed that electrons could be diffracted,
Okay.
just like light waves,
Interesting.
when passing through a crystal.
So they weren't directly seeing these electron waves,
Well-
but rather the pattern they created.
Exactly. They observed the pattern
Okay.
made by the diffracted electrons,
Mm-hmm.
and it perfectly matched what you'd expect
Yeah.
if electrons were behaving like waves.
Okay, so think of it like
Yes.
shine a flashlight
Mm.
through a narrow slit, you get a beam of light,
Right.
but with electrons instead of a beam.
Yeah,
It's
so-
like a wave spreading out,
Yes.
just like that image
Yeah.
of de Broglie waves. The one showing a particle represented by a line,
Yes.
also exhibiting wave-like properties.
Right.
It really helps to visualize something so abstract.
Visualizations are key, for sure.
Yeah.
And this experimental confirmation
Yeah,
was monumental.
I bet.
It earned de Broglie the Nobel Prize in Physics
Wow.
in 1929.
Good for him.
But his work had implications far beyond the subatomic world.
So he wasn't content with just proving electrons had wave-like properties.
No, he wasn't.
He felt all matter acted this way.
Precisely. He believed wave-particle duality
Yeah.
applied to everything,
Wow.
even macroscopic objects. Imagine a baseball flying through the air.
Okay.
According to de Broglie,
Yeah.
that baseball also has a wave associated with it.
So every baseball,
Yes.
every frisbee,
Uh-huh.
everything has an invisible wave. Mind-blowing, isn't it?
Yeah, but if the wavelengths are so tiny,
Yeah.
why don't we see things acting like waves?
That's the key point.
Yeah.
The wavelength of something like a baseball
Mm-hmm.
is so incredibly small.
Yeah.
It has no noticeable impact.
On how it moves.
Right. Or how we perceive it.
But the implications are huge.
Oh, absolutely.
So he wasn't just describing electrons.
Right.
He was making a fundamental statement
Yes.
about the nature of reality itself.
Exactly. It's like he took this tiny particle, the electron,
Yeah.
and used it to unlock this whole new understanding.
Of how everything in the universe behaves.
I like that analogy.
Yeah.
And that's only the beginning.
Oh, really?
His work was pivotal in the development of wave mechanics.
Interesting.
It directly influenced Erwin Schrödinger,
Oh, wow.
who developed the mathematical equations
Okay.
to describe these matter waves.
So this one physicist, with his unconventional background,
Yeah.
helped reshape the entire landscape of physics.
I'd say that's amazing.
De Broglie's work was a turning point.
Yeah.
It challenged the traditional model of the atom and ushered in this strange, probabilistic world
Right.
of quantum mechanics.
Right.
And he didn't stop there.
Really?
Later in his career,
Yeah.
he even proposed that electrons have
Uh-huh.
a kind of internal clock.
An internal clock.
Yeah.
What does that even mean? Are we
Right.
talking about like a tiny timekeeper inside every electron?
It's a concept
Yeah.
that's still being explored today.
Really?
Some physicists, like David Hastings,
Okay.
have linked this idea to a phenomenon
Okay.
called Zitterbewegung.
Zitterbewegung.
Yeah,
Okay.
a kind of rapid oscillation
Oh.
predicted to occur within particles.
Got it.
De Broglie was pondering these concepts decades ago.
It seems like his mind was always pushing the boundaries
It
of
was.
what we know about the universe.
Definitely.
But before we get too deep into that,
Yeah.
let's bring it back to the real world. How did these discoveries change things for us non-physicists?
Well, for one,
Yeah.
de Broglie's work led to the development of electron microscopes.
Electron microscopes.
Yeah.
Okay.
These microscopes use the wave properties of
Yeah.
electrons
Right.
to create highly detailed images
Mhm.
of incredibly tiny objects.
So things we could never see
Right.
with the traditional light microscope.
Exactly.
So are we talking about seeing things like viruses?
Yes,
Or even individual atoms?
exactly.
Wow.
And that's had a huge impact
Yeah.
on so many fields.
Like,
Biology, materials, science, nanotechnology.
wow, the list goes on.
It does.
So this wasn't just theoretical physics
Oh.
happening in a vacuum.
Nope.
De Broglie's discoveries have had tangible, real-world applications
They have.
that have changed the way we live
Yes,
and understand the universe.
absolutely.
Yeah.
And his ideas
Yeah.
continue to inspire new research and discoveries to this day. It's a testament to the power of scientific curiosity
Yeah.
and the impact a single person's ideas can have.
It makes me want to go back and read more about him.
You should. I highly recommend it.
Yeah.
It's a journey into the mind of a brilliant scientific thinker.
Definitely.
But remember,
Yeah.
his story began with a deep dive into history.
Right.
And then he went on to make his own history.
In the world of physics.
That's right.
It's interesting how his background
Yeah.
might have played a role in his thinking.
Mm-hmm.
You mentioned earlier that
Yeah.
he came from a family of French nobility.
I did.
What was that like for him?
Well, his family was quite prominent.
Okay.
His father was the 5th Duc de Broglie.
Wow.
Their family tree included military leaders and politicians going back centuries.
So imagine this.
Okay.
Louis de Broglie grows up
Yeah.
surrounded by history and tradition,
Right.
maybe even in a castle.
It's possible.
And then he turns the world of science upside down.
I know. It's quite a story.
It really is.
And it wasn't just his family history
Yeah.
that influenced him.
What else?
De Broglie was also deeply interested in the philosophy of science.
So it wasn't just equations and experiments for him.
No,
He was thinking about the bigger picture, the
Yeah.
meaning behind it all.
absolutely. He saw wave-particle duality
Yeah.
as a fundamental principle of nature,
Wow.
something more profound
Yeah.
than just a description of how particles behave.
So he was seeking a deeper truth about the universe.
He was.
And he wasn't afraid to explore unconventional ideas,
Yep.
like that concept of an internal clock for electrons.
Right. That idea,
Mm-hmm.
while still being debated today,
Yeah.
highlights how forward-thinking he was.
Definitely.
De Broglie was constantly pushing the boundaries.
Of scientific thought.
Yes, not just in physics,
Yeah.
but in its philosophical implications as well.
It makes you wonder
Yeah.
what it would have been like to have a conversation with him,
Oh, yeah.
to pick his brain about his ideas.
That's a fascinating thought experiment.
It is.
It speaks to the enduring legacy of his work.
So we've covered the basics of de Broglie's big idea.
Okay.
Wave-particle duality,
Mhm.
its famous equation,
Yeah,
the experimental proof.
right.
It's a lot to take in,
It is.
but incredibly fascinating.
It is. But what's even more fascinating
Yeah.
is how these discoveries changed the way we understand the universe.
Right, because this wasn't just about electrons.
No.
De Broglie suggested that wave-particle duality applied to everything.
Yes.
So how does that change our view
Right.
with the physical world?
It challenges our everyday intuition. about
Sure.
the world.
Okay.
We think of things as being solid, predictable.
Right.
But the Broglie showed us
Yeah.
that at a fundamental level,
Hmm?
things can behave in ways
Okay.
that defy our expectations.
It's like he gave us a glimpse behind the curtain of reality.
I like that.
And what we see is both beautiful and mysterious.
Exactly. And it's a reminder
Yeah.
that there's always more to discover, more to learn.
Definitely.
Even the seemingly mundane can hold profound secrets.
It's inspiring to think
Yeah.
about how much more there is to learn about the universe and our place in it.
It really is. And who knows?
Yeah.
Maybe one of our listeners will be the next de Broglie,
Oh, wow.
making groundbreaking discoveries
Yeah.
that challenge our understanding of the world.
Okay, so we've explored de Broglie's groundbreaking work on wave-particle duality,
Yeah.
delved into the philosophical implications,
Right.
and even touched on that mind-bending concept
Yes.
of an internal clock for electrons.
Hmm.
But before we wrap things up,
Okay.
I'm curious about de Broglie the person.
Okay.
What was he like?
From what we know,
Yeah.
de Broglie was a very private and introspective individual,
Okay.
known for his intellectual rigor,
Yeah.
his dedication to his work.
Mm-hmm.
He wasn't one to seek the spotlight, but he was deeply respected by his colleagues.
So not exactly the life of the party.
Not that we know of.
Okay.
He seemed to find his greatest joy
Yeah.
in exploring the mysteries of the universe
Mm-hmm.
and contemplating the philosophical meaning of his discoveries.
It sounds like he lived in two worlds.
Yeah.
The world of scientific exploration and the world of deep thought.
That's a beautiful way to put it.
Yeah.
I think it speaks to the depth of his intellect.
Definitely.
He wasn't just a physicist.
Yeah.
He was a truth seeker,
Uh-huh.
a philosopher of nature,
Yeah.
a man dedicated to unraveling the secrets of the cosmos.
It makes me wonder,
How cool.
what was it like to talk to him?
Yeah.
What kind of amazing ideas might he have shared over a cup of coffee?
Now, that's a conversation I would have loved to be a part of.
Me too.
Yeah.
It's inspiring to think about the legacy he left behind, not just his scientific discoveries,
Right.
but also his way of thinking,
Yes.
his approach to the world, that desire to understand not just the what, but also the why.
He set a high bar for all of us who follow in his footsteps.
He did, from the halls of French nobility
Mhm.
to the frontiers of quantum mechanics.
Yeah.
Louis de Broglie's journey is a testament
Uh-huh.
to the power of human curiosity,
Yes.
the beauty of scientific discovery,
I agree.
and the boundless potential of the human mind.
Well said. And on that note,
Yeah?
I think it's time for us to wrap up this deep dive.
Into the fascinating world of Louis de Broglie.
Oh, that's right.
But before we go,
Yeah.
let's leave our listeners with something to ponder.
Okay.
If, as de Broglie suggested, even solid objects have wave-like properties,
Yes.
what does that say about the nature of reality itself?
That's a big one.
Are we all just waves interacting and interfering with each other
Maybe.
on some fundamental level?
It's a question
Yeah.
that continues to fascinate both physicists and philosophers.
That's something we can all consider
I agree.
as we go about our daily lives,
Yeah.
noticing the beauty and strangeness of the universe we inhabit.
Well said. Thanks for joining us
Yes, thank you, everyone.
on this deep dive into the world of Louis de Broglie.
We hope you found it as thought-provoking as we did.
Yes,
Bye.
definitely. Until next time,
Keep exploring, keep questioning.
and keep diving deep.
We'll see you next time.
See ya. It's a concept that physicists are still exploring.
Wow.
Some physicists, like David Heston's,
Okay.
they've linked this idea to a phenomenon called Zitterbewegung.
Zitterbewegung.
Yeah,
Okay.
it's a kind of rapid oscillation predicted to occur within particles.
Oh, so de Broglie was ahead of his time,
Okay, found.
thinking about these things decades ago.
Yeah, way ahead of time.
But, before we go too deep into that rabbit hole,
Sure.
I want to bring it back to the real world for a sec.
Okay.
How did this discoveries about wave-particle duality
Yeah.
change things for us non-physicists?
Well, for one, de Broglie's work led to the development of electron microscopes.
Electron microscopes.
Yeah, you know those microscopes?
Yeah.
They use the wave properties of electrons
Okay.
to create highly detailed images
Uh-huh.
of incredibly tiny objects.
So things we could never see with like a regular microscope.
Exactly. Things a traditional light microscope
Right.
can never reveal.
So are we talking about seeing things like viruses?
Oh, yeah.
Or even individual atoms?
Exactly.
Wow.
And that has had a huge impact
Yeah, I bet.
on so many fields.
Like what?
Biology, materials, science, nanotechnology.
It's incredible
It really is.
to think about
Yeah.
how this seemingly abstract idea has led to such tangible advancements.
Yeah, it's not just theoretical physics
Yeah.
happening in a vacuum.
De Broglie's discoveries have had real-world applications.
Absolutely. They've changed the way we live.
And understand the universe.
I think that's a great way to put it.
That's amazing.
And you know what? His ideas continue to inspire new research and discoveries,
Really?
even to this day.
It's a testament to the power of scientific curiosity
Absolutely.
and the impact a single person's ideas can have.
I couldn't agree more.
It makes me want to go back and read more about de Broglie.
You should. It's fascinating.
Yeah.
I highly recommend it.
A journey into the mind of a brilliant scientific thinker.
Exactly. And his story,
Sure.
it began with a deep dive into history.
Right. He started out studying history.
He did. And then he went on to make his own history.
In the world of physics.
I love that.
It's really interesting how his background
Yeah,
might have played a role in his thinking.
I think so too.
You mentioned earlier that he came from a family of French nobility.
Right. His family was very prominent.
I mean, what was that like for him?
Well, his father was the 5th Duke de Broglie.
Wow.
I mean, their family tree.
Yeah.
It included military leaders
Wow.
and politicians going back centuries.
It's kind of hard to imagine.
I know, right?
Louis de Broglie, growing up.
Yeah.
Surrounded by history and tradition.
Maybe even in a castle. Who knows?
And then he goes on to turn the world of science upside down.
It really is an incredible story.
It is.
And it wasn't just his family history that influenced him.
Oh, there was more.
De Broglie was also deeply interested in the philosophy of science.
So it wasn't just equations and experiments
Nope.
for him.
He was thinking about the bigger picture,
Yeah.
the meaning behind it all.
It sounds like he was searching for something deeper.
He was.
Yeah.
He saw wave-particle duality as this fundamental principle
Uh-huh.
of nature, something more profound
Right.
than just a description of how particles behave.
Like he was trying to unlock a hidden truth about the universe.
I think that's a great way to put it.
And he wasn't afraid to explore unconventional ideas.
No, he wasn't. Like
Okay.
that concept of an internal clock for electrons.
Right. That idea is still being debated today.
It is, but it just shows how forward-thinking he was. De Broglie was constantly pushing the boundaries of scientific thought.
Not just in physics.
Right, but also in its philosophical implications.
Yeah, it's really fascinating.
It makes you wonder
Yeah.
what it would have been like to have a conversation with him.
To just sit down with him
Yeah,
and pick his brain about these ideas.
that's a great thought experiment.
It really is.
It speaks to the enduring legacy of his work.
Okay, so we've covered the basics of de Broglie's big idea.
Okay.
Wave-particle duality,
Yeah,
his famous equation, the
Mhm.
experimental proof.
right.
It's a lot to take in,
It is.
but it's incredibly fascinating.
It is, but you know what's even more fascinating?
What's that?
Is how these discoveries change the way we understand the universe.
Right, because this wasn't just about electrons.
No, it wasn't.
De Broglie was suggesting that this wave-particle duality
Uh-huh.
applied to everything.
To everything.
So how does that change our view of the physical world?
Well, it challenges our everyday intuition about the world. I mean, we think of things as being solid,
Yeah.
predictable. You know?
Right.
But de Broglie showed us that at a fundamental level,
Uh-huh.
things can behave in ways that defy our expectations.
It's like he pulled back the curtain on reality.
I like that.
What we see is both beautiful and mysterious.
Exactly. And it's a reminder
Yeah.
that there's always more to discover,
Mm-hmm.
more to learn.
Definitely.
Even the seemingly mundane can hold profound secrets.
It's inspiring to think
Yeah.
about how much more there is to learn about the universe and
Right.
our place in it.
Really is.
Yeah.
And who knows?
Yeah.
Maybe one of our listeners will be the next de Broglie,
Wow. That would be amazing.
making groundbreaking discoveries that change everything,
That would be incredible.
challenging our understanding of the world.
Yeah. It really is a mind-boggling concept.
It is.
You know, we spend our lives interacting with a world that feels so solid,
Right.
predictable, but then quantum mechanics comes along and says, at its most fundamental level, it's all just waves.
waves.
It challenges everything we think we know about reality.
It does. It really challenges our perceptions.
Yeah.
But that's the beauty of science.
Okay.
It pushes us beyond our comfort zones
Mm-hmm.
and expands our understanding of the universe.
Definitely.
And de Broglie's legacy
Yeah.
is a testament to that.
I agree.
He wasn't afraid to ask those big, challenging questions.
Yeah.
And his insights,
Mm-hmm.
they continue to ripple through the world of physics today.
It's incredible to think
I know, right?
that one person's curiosity
Yeah.
and willingness to challenge conventional wisdom
Uh-huh.
could have such a lasting impact.
It's amazing.
But I think what makes de Broglie's story even more compelling
Yeah.
is that he wasn't just a brilliant scientist.
Right.
He was also a deep thinker,
Yes.
grappling with the philosophical implications
Absolutely.
of his discovery.
He was thinking about the big picture.
He saw wave-particle duality
Yeah.
as more than just a scientific principle. He saw it as a fundamental truth about the nature of reality.
Exactly. And that's something we haven't fully explored yet.
Yeah, you're right.
We've talked about his scientific achievements.
Right.
But what about the man behind the science?
Yeah, what about de Broglie, the person?
Exactly. What were his personal beliefs?
Right.
His motivations?
What shaped his worldview?
How did his background and experiences shape his thinking?
I'm really curious about that.
Yeah.
We know he came from a family of French nobility.
Right, with a long history of military leaders and politicians.
Yeah, he could have easily followed a more traditional path.
He could have.
But instead, he chose to pursue science.
And ended up making one of the most significant breakthroughs
In modern physics.
It's incredible.
What drove him to make those choices?
Well, I think it was a combination of factors.
Okay.
Definitely intellectual curiosity,
Uh-huh.
a desire to understand the world around him.
Right.
But, there might also be
Yeah.
a deeper, almost spiritual motivation at play.
Oh, really?
I think de Broglie saw beauty
Yeah.
and elegance in the laws of physics.
Okay.
And he believed that understanding those laws was a way to connect with something greater than himself.
That's a really interesting perspective.
It is.
It suggests that for de Broglie, science wasn't just about equations
Right.
and experiments.
It was about something more.
It was about seeking truth and meaning in the universe.
Exactly. And that pursuit
Yeah,
led him to some truly profound insights.
definitely. And I think that's a valuable lesson for all of us.
I agree.
Whether we're scientists or not,
It doesn't matter.
we can all benefit from cultivating a sense of curiosity
Yes.
and wonder about the world around us.
Absolutely. We can all ask those big questions.
Right.
And seek deeper meaning in our own lives.
I completely agree. And perhaps
Yeah.
by following in de Broglie's footsteps,
Uh-huh.
embracing that spirit of inquiry
Yes.
and open-mindedness,
Hello.
we can unlock new discoveries and perspectives
That would be amazing.
that enrich our understanding
Of ourselves.
of ourselves and the universe we inhabit.
Well said. I completely agree.
So as we conclude our deep dive
Okay.
into the world of Louis de Broglie,
Yeah.
we want to leave you with a final thought.
Okay, shoot.
It's a thought that reflects the profound impact of his work
Yeah.
and the enduring questions he raised
Uh-huh.
about the nature of reality.
Okay.
If, as de Broglie suggested,
Yes.
everything,
Yeah.
even seemingly solid objects,
Yeah.
possesses wave-like properties,
Right.
what does that mean for us?
That's the question, isn't it?
Are we all just waves, interconnected,
Yeah.
influencing each other
Maybe.
in ways we may never fully comprehend?
It's a question that invites contemplation
It really does.
and wonder.
And while we may not have all the answers,
Right.
the act of asking these questions,
Yes.
of exploring these ideas, is what keeps the spirit of scientific discovery alive.
I think you're absolutely right.
So as we sign off,
Okay.
we encourage you
Yes.
to keep exploring,
You questioning
keep questioning, and keep diving deep.
into the mysteries of the universe.
You never know what incredible discoveries await,
That's right.
just beyond the horizon.
Absolutely.
Thanks for joining us
Yes, thank you.
on this journey into the world of Louis de Broglie.
It's been a pleasure.
We'll see you next time for another deep dive.
See?